In this circuit we need to find I1, I2 and V0. Also we need to show that the power supplied by this source, there is only one source, so the power supplied by the source is equal to the power dissipated by the resistors here. So in order to find the currents and voltage, what shall I do first is, we can see that this branch here and this branch, series combination of two resistances, these two are in parallel, and the voltage across those branches, because they are parallel, the voltage is same, and that is V0 equals to I1 times 100, I1 times 100, or I2 times 150 plus 200, 150 plus 250. So that gives us, because these two are parallel, the voltage drop across the 100 ohms resistance is 100 times I1, and voltage drop across 150 is 150 times I2, and 250 is 250 times I2, and they are added, so that's why it's like this. So from that I can write 100 I1 is equal to 400 I2, which means I1 over I2 equals to 4. So I1 can be written as 4I2. Now we know this is a current source here, and I1 and I2, sum of I1 and I2 has to be 1.5 amps, because that is the current which is coming in this way, and it is split here. I1 is going in that direction, I2 is going in that direction. So I1 plus I2 will be 1.5. So I1 plus I2 equals to 1.5, which gives us 5I2 equals to 1.5, because 4I1 I1 is equal to 4I2 plus I2. So I2 equals to 0.3 amps, and I1 becomes 4I2, so 1.2 amps. So this we know now. Since we know this, we can write V0 as well. V0 is 100 times I1, that is easier. So 100 times I1 is 1.2, which is 120 volts. First, let us calculate the power supplied by the source, which is this one. The power supplied will be this current times the voltage, which is V0. So power supplied, if I say PS, that will be V0 times 1.5. It is 120 times 1.5, which is 180 watts. So that is the power supplied. Now we need to find power dissipated. That will be power dissipated in this resistance and dissipated in these two resistances, 150 and 250. So we can find it, I will try to find it this way. So V0 I1, that is the power dissipated by 100 ohms resistance, and plus V0 I2, that will be power dissipated by 150 and 250 resistances together. So the total power dissipated from here to here because of these two resistances. I could have used P is equal to I square R. So P100 will be I1 square R, which is 100. That I could have used. And then P150 would be I2 square into 150. P250 would be I2 square times 250. That could be done, but this probably will be easier, I think. So like that. So this will be 120 times I1 is 1.2, and 120 times 0.3. 120 times 0.3. So this one becomes 144, and this is 36. So total power is 180. So this is power dissipated. Total power dissipated and total power supplied, they are equal. Now I will calculate them as well using I square R. So that would be power dissipated I1 square times 100 and I2 square times we can actually sum up the resistances. We don't have to calculate because we want to find the total current, and the current is same here in 150, and these are two in series, so I can add the series resistances together and then multiply by I2 square because it's the same current. So if I do that, what I get here is 400. So 1.2 square times 100 plus 0.3 square times 400, and we can see there will be the same 144 and 36, because with VI we will get the same power as I square R. This is the power dissipated in 100 ohms, which was same here, and this is power dissipated by 150 and 250 ohms resistances together. So again 180 watts, same result. I just calculated with a different formula, with the other formula for power. So that's I square R, and power dissipated here again same as power supplied.